chapter 17, section 7 notes today. And we're going to be looking at two different types of hydrocarbons. And we've got alcohols and we have ethers. So if you look at that page, there's that page that I put on there for you guys a while back that had all the different ones listed on there. You can find the alcohol and ethers there, and this section will just focus on those. So let's jump into it. Maybe. There we go. All right, so alcohols contain a hydroxyl, or what is called an OH. So you are talking just straight carbons with an OH on there. And then phenols are the benzene ring with the OH on there. So I'll tell the kids that they can draw that. They can draw, you can see how it's drawn here. You'll see it drawn a lot of times like this. And you'll just see the OH. So instead of having that line and then a line there, you'll see it drawn like this. And that is called phenol. So I'll tell them that they can write that down on their papers that they can have out during tests or whatever. All right? So then if you don't have a benzene ring and you just have this is a single carbon, so which is meth, and then there's an OH here. So it's showing the difference between this and water. It's very similar to water, OH, but there's just another hydrogen, OH, and then we get that carbon. It does not act like water at all, but to look at that structure, it looks similar to water. All right. So we name alcohols by ending them in OL. So we know with alkanes, we ended them with A and E. So we had like pentane and hexane and heptane. And then we had our double bonds, so pentene. And our triple bonds, which would be pentyne. Now we're jumping into this. So we're always changing the endings. Those prefixes for how many carbons there are always going to be the same. We're just going to change the ending to an OL. So if you look at this, we're just going to do the simplest one, which is a single carbon. This is methane. Now, if I have a single carbon attached to an OH, it is now methanol. So we're getting rid of that A and E and adding an OL, methanol. And you'll really hear me say all versus al because there's one coming up where the ending changes it to an AL. So it's really important that when you're writing these out, I can tell that it's an OL. Here's the next one is ethane, 2 carbons. Now that I have this OH here, ethanol or ethyl alcohol. You can see over the side here where they're saying methyl alcohol or ethyl alcohol. Both of them are correct. So I don't know, but you'll see me use the OL mostly. That's mostly what I'll use. All right, so here's some for a little bit longer chains. Now, once again, I'm going to go back again real quick, sorry. If you look, no matter where I put the OH, let me get rid of all this. Let's say that my OH, instead of being here, it was coming off the top or the side or the bottom. It's still on that carbon 1. All right, now look at ethanol. What if I moved this OH and I moved it over here? It would still be 1 ethanol. So no matter where I put this OH, it's still on carbon 1. So that's why there are no numbers here. But when we get into our longer chains, you have to start putting that, especially when you start with a prop. The OH, we see a OH, so right away I know it's an alcohol, and I'm going to end it in OL, so propanol, but I have to put the 1. If you don't put the 1, I'm going to assume it is a 1. So because the other option here, I could have done this. I could have put the OH here. And now it becomes 2 propanol. And it may seem like that's not a big deal, but it really is. In the world of chemistry, these little bitty changes can change so much about a particular atom or molecule. And how it acts, how it reacts. So it is important that we know where that is. So you can see they just did what I did here a second ago to make it 2 propanol. And then here we have one with a branch. You can still get branches off of this thing. I'm still going to do like I've always done and find my longest chain. So this is going to be my longest chain. And it is 1, 2, 3, 4, 5, 6. The prefix for 6 is hex. Now, normally I'd be like, oh, that's hexane. But as soon as I see this OH, I know it's going to be hexanol. And I have to put where that OH is. Now, I could count 1, 2, and that gets me closest to that methyl, but when you have these special groups, whether it be a double bond, a triple bond, now we're doing OHs, you're going to count closest to that OH. So you can see up here, it says number of the chain from the end nearest the OH. So 1, 2, that becomes carbon 2. So it is 2-hexanol, but I still have to name my methyl. And I know it's methyl because there's a single carbon. So 1, 2, 3, 4, 5. So we have 5-methyl 2-hexanol. So each section is going, we still have those basic rules for naming, but we're going to add little bits in each section from here on out. All right, so name the following alcohol. So remember, your first step for A is going to be finding what is your longest carbon chain, and that one's pretty easy to find here. So once you find that, then how many carbons are there? What is the prefix for that? So we have 4 carbons, so that's going to be bute. Now normally I would have butane, but I see that there's an OH. As soon as I see that OH, I'm like, oh, it's going to end in OL. So it is butanol. Now I need to tell where that OH is at. So 1, 2. The answer is 2-butanol. And remember, if you ever get stuck, you do have that special sheet that I gave you. You could look on there and be like, oh, an OH, what is that? And you could look and see it's an alcohol. And there's even an example on there to show you how to name one. All right, on B, same thing. I'm going to find my longest chain. Now, here's what I see kids do a lot of times. They want to do this and circle that OH in there. Remember, that is not. I'm looking for my longest carbon chain. Just carbon, that's it. So this is 1, 2, 3, 4. My longest is 4, so it's bute. But instead of butane, this is going to change it to butanol. And that is on carbon 1. But now 1, 2, here's a methyl. So off of carbon 2, I have a methyl. So then you just combine all of this together, and you have 2-methyl, 1-butanol. Once again, if I don't put that 1 in there, I'm assuming it's a 1. So if I just put 2-methyl-butanol, that's fine, and that's another way to name this. When you don't put the number, I'm assuming it's a 1. All right. Phenol. This is that benzene ring with the OH on there. So it's, I mean, that's basically it. It's used in antiseptics, disinfectants, so some medically cleaning type stuff. Is where we see this structure. Now that doesn't mean that it's just that structure right there. There may be some other things on there, but the base structure is a phenol. So a benzene ring with an OH. I can almost guarantee that on some worksheet I'm going to have just this benzene ring with an OH, and it is phenol. Once again, you can write that down somewhere special that's easy to find, or if you can just find it in your notes, that's okay too. All right. We also classify alcohols, and there's a reason behind this. So I'm going to classify them, and then I'll show you what happens to them. So what I'm looking at, and this sometimes confuses kids because they see this OH, and I'm like, look at this. If we just looked at the OH and looked at how many carbons is attached to that OH, it's always 1. Look, there's 1. Look, there's 1. There's 1. It will be that way every single time. Every single time you have an OH, there's only 1 carbon attached to it. So when I'm classifying these, I'm not looking at the carbon attached to it. I don't care about this one. When I am classifying it, I'm looking at how many carbons are attached to that one. So basically, how many carbons are attached to the COH? Maybe that's a better way of looking at it. So how many carbons are attached to this COH? Well, there are 1, 2. So that's why it's secondary. This is why this one was primary. And then tertiary, how many carbons are attached to that COH? 1, 2, 3. Now what I see is kids getting the notes and they're like, okay, that makes sense. And then they get a worksheet and I ask them and they will tell me primary. Every time they'll tell me primary. And I'm like, no, remember, it's not this carbon, but the carbons attached to that one. How many are there? All right, so just something that I see a lot happen, some just little common mistakes. But why we care about that? Let's classify that and then I'll get into why we care about that. So if we're looking at A, remember we find our OH and we look at the C that many carbons is connected to this? This is 1. So this is a primary. If we're looking at B, let's find our OH. Now, how many carbons are attached to this? And there are 1, 2. So that is secondary. Let's find my OH. Now let's look at the COH. How many carbons are attached to that? 1, 2, 3. So this would be called tertiary. Or if you can see how I write the numbers up there, that's another way. That primary is a 1 with almost like a degree sign at the top. Secondary the same way, and tertiary is the same. All right, so that's it. Now, I wish they would have done ethers first. That's it for that. We'll see them again appear here in a second. We'll talk about the tertiary, secondary, primary, all that. But let's go ahead and look at ethers. To me, I think these are probably the easiest to name. You're not getting branches, you're not getting chains, you're just getting 2 carbon chains coming off of each oxygen. So if you look at this, you have an oxygen, you have a carbon, and a carbon. Oxygen, carbon, carbon. So once again, this is also on that special sheet I gave you. And look how you name these. You literally name them by what's on each side of it. You have an methyl, and I have an ethyl. So it's ethyl, methyl, ether. And that's it. Or if you have 2 methyls, then it's just dimethyl ether. All right, once again, that's on that special sheet. They have ways of naming those, or they have an example of naming that. All right, so now we're going to write the structure. And I always think that this is easier than naming. These tend to be a little bit easier for kids. So as I see the pent and I see the OL, but pent tells me I'm going to have 5 carbons. So I'm going to go ahead and put my 5 carbons up here. And it's OL on, so I've got a OH on carbon 3. So 1, 2, 3, I'm just going to put it down like this. I could have put it coming off the top, it doesn't matter. I just had more room on the bottom. And that's 3-pentanol. Now, let me add my hydrogens. 1, 2, 3, 4. That one just needs 1. So another way to write this would have been CH3, CH2, CH, CH2, CH3, and then on the CH put my OH. So we could do that too. That would be a condensed structural formula. All right, now my ether. When I see ether, what I do, or what you can do, I see diethyl, so I know there's going to be 2 ethyl groups, which means F means 2. So I'm doing that. But you could see ether and be like, okay, oxygen. Now what's on each side of my oxygen? Oh, there's 1 ethyl, here's another ethyl. So that's one way of doing it. And then make sure your hydrogens are there. Oxygen only needs 2 lines. Here's the reason why. If you look at your periodic table and remember back from chemistry 1, which was forever ago, oxygen has 6 valence electrons and they all want 8. Hopefully that rings a bell. So oxygen just needs 2 spots, 2 bonds. So that's why oxygen's happy the way it is right there. All right, there's the solution. All right, here we go back to the oxidation. I really wish they would have just put this right there with the rest, and I'm going to see if I can change that myself. All right, so oxidation of primary alcohols. So when I hear oxidation, what element do I think of? Oxidation. So I think of oxygen. So, and that's exactly what I'm doing is I'm adding oxygen, and you'll soon see that anytime I add oxygen, my hydrogens attract to it immediately and it forms water. So that's what we're doing here. So I've got my primary alcohol, and remember what makes it primary? I'm going to circle that COH, and there's only 1 other carbon attached to it, so that's why it is primary. So here's what happens. I add oxygen, right? Now oxygen is going to take the hydrogens from this one of these. Now it could have taken this one. I'm just picking, they just picked one. And it's going to take the hydrogen from the OH. When it does that, when it takes this and this away, my carbon, this line's gone, my carbon is no longer happy, and neither is my oxygen. All right, so what happens, how they make each other happy is they double bond. All right, so I'm adding an oxygen. It's going to take 2 hydrogens to make water, and you can see that here. They have my 2 hydrogens it took in blue. And so now I have water, plus it changed it to an aldehyde. Now, we have not learned about aldehydes yet. We will soon, but that is what it's changed it to, a double bonded oxygen on the end of the chain. So the reason why it takes these, because I have kids ask me sometimes, why those hydrogens? Why does it take the hydrogens from that specific carbon, from this carbon, and from this oxygen? Why doesn't it take one from over here? Well, that's because when that happens, like this can double bond to oxygen to make it happy. That does not happen with this. Okay, we don't get a double bond there to make it happy, so that's why that happens. All right, let's look at a secondary. Once again, I see this and right away I know it's an alcohol. So for oxidation, I'm adding oxygen. So when I add oxygen, it's going to take the hydrogen, remember, from the OH and from the carbon it's attached to. So when it takes those, carbon is not happy anymore, neither is oxygen, so they double bond. And you end up with some water. Now this happens to be a ketone. It will make either an aldehyde or a ketone. The reason the last one was an aldehyde is because that double bonded oxygen was on the end of the chain. This one is directly in the middle. It's in the middle of the chain. So that makes it a ketone. Like I said, we'll learn about those later, but that's where they're getting these names and the endings and all that good stuff. Let's look at tertiary. So remember, it's always oxidation is adding oxygen, and it's going to take the hydrogen here and a hydrogen from this carbon, but there are none. There are no hydrogens to take. I know it says CH3. Let me draw this out to maybe make a little bit more sense for you. This is what it is if you were to draw those lines out. Now, they write CH3 like this. So it almost looks like that carbon's connected to hydrogens, but it is not. Don't let that fool you. It looks like this. So this carbon right here is going to take that hydrogen, and there are no hydrogens to take from this middle carbon. So it will not work. You cannot oxidize a tertiary alcohol. It just won't happen. So if you see in a homework question, if you see an oxidation problem and it's tertiary, you'll just write not possible. Okay, so here's why oxidation matters to us so much, or hopefully maybe not. But in the body, enzymes in the liver oxidize ethanol. So anybody that has any alcohol, we know that it's your liver that is cleansing and getting rid of waste. And it's the enzymes in there, and how they're doing that is they're oxidizing. So what happens is you have alcohol, maybe it's ethyl alcohol, and it oxidizes and it performs an aldehyde. Now that aldehyde is what impairs people. So we say it's the alcohol. Technically, yes, it's the alcohol, but it really is the breaking down of the alcohol. The oxidation of that alcohol is what impairs people. That's why blood alcohol over 0.4% can be fatal, because you have this buildup of, look at the very end where you see ethyl alcohol, it turns into acetaldehyde. It eventually turns into acetic acid, which turns into CO2 and H2O. Not good to have that much CO2. So that's why that happens. So let's look at the learning check. It says select the product from the oxidation of, and now if I were to name this 1, 2, 3, propanol, 1 propanol. All right, so I'm going to do the oxidation here. So remember, oxidation, I'm adding oxygen. It is going to come and steal that hydrogen from oxygen, and it is going to come and steal the hydrogen from that carbon that's attached to it. So now what you have is you have this, remember, they're not happy anymore, so it's going to double bond to that oxygen. So look, it's not this one doesn't even have oxygen. This one, the oxygen's in the middle, not the case up here, so it's not 2, it is this one. Double bonded oxygen on the end, that forms an aldehyde. Once again, I'm just kind of saying this to get you prepared because aldehydes are coming up, but we don't need to know them yet. All right, and that's it for 17.7. I know there's quite a bit. Anytime I throw in an equation with the notes, kids, I think, can sometimes get a little overwhelmed, but let me know if you need anything or if you have any questions on the oxidation. I always worry about those chemical formulas and the equations, making sure that you guys know what's going on. So let me know if you need anything, even if you just want me to, like, hey, can you check these problems for me? I have no problem doing that. I hope you have a great rest of your day, and I will talk to you later. Bye.